Friends, welcome to my YouTube channel Concept Clear with a new video of learning and growing. I hope these videos will help you to improve your skills and knowledge, and you will get some benefit from it in your life. Without any delay, let's go to the topics that I am going to discuss today. So today we'll see that what is a full adder, how you will get the output expression, what is it. Then after getting that, I will write the Verilog code of that full adder in Dataflow and Behavioral Modeling. Then after writing the design source, then we'll write a test bench. With the help of the test bench, we'll verify the full adder. So let's go to the Vivado tool. Before going to the Vivado tool, let us understand the full adder. In a full adder, there will be three inputs A, B, C in. Two output will be there, sum and carry. So here you can see this one, this is the full adder. And the truth table of that full adder, if you'll see, so this is the truth table. A, B, C is input and sum and carry as output. If you are giving 0, 0, 0 input, then output sum will be 0, carry will be 0. How it is coming? 0 plus 0 is equal to 0. Again 0 is added. So 0 plus 0 is equal to 0. Like that it is coming. So by using this logic, by this sum logic, we are getting this truth table, and by solving this truth table with the help of a K map, we'll get the expression for sum and carry, which is the output. So what is the expression of sum and carry that I am going to write here? For sum, you will get the expression like this. 3 input A, B, C in is there, so you'll get A XOR B XOR C in. Similarly, for carry, you will get carry or carry out. You will get the expression like AB plus BC plus CA, or it can be written in another way like A XOR B into C in plus AB. Both are same. Okay. So now, since we are going to write the code in Dataflow modeling or behavioral modeling, in that we don't have to go in circuit level. We have to only know how the data is flowing from input to output, or what is the expression of output in terms of input. As you can see here, sum is the output. Its expression is A XOR B XOR C in. Carry is the output. Its expression in terms of input A, B and C in as AB plus BC in plus C in A, or A XOR B into C in plus AB. Okay, so by the help of these two expressions, we have to write the Verilog code and we have to verify it. So now let's go to the Vivado tool. Now this is the Vivado tool. Now here we have to add source. Then here we have to select the add or create design source. Next we have to give the file name. We have to create a file. I have given full adder underscore D, that means Dataflow modeling. Then okay. So already it is exist. Earlier I have made some file, so I like full adder underscore D1. Okay. Then we have to go to finish. So now you will ask what are the input and output terminals. If you want, you can change the module name here, and we have to give the input port and output port here. So here we'll have three input port like A, B and C in. You can write in capital A, B, C in, three inputs. Then we have to write output. Output is just sum and carry, so you can write here sum and carry. Then okay it here. So now you can double click here and you will get the window here. So now I have to write my code in terms of data flow modeling, means how the data is flowing from left to right. Since it is a data flow modeling, so you have to use the keyword assign. By using the assign keyword, you have to write the statements. So I'm writing here. So this code is very simple. You have to write assign sum, which is your output, is a xor b xor c in. This symbol is representing that xor. Then assign carry is equal to a and b, or that means plus symbol a xor b into c in. Okay, this is very simple. Only with from the output expression only you have to write it. Then we have to save it. So after that you have to check whether any error is there or not in the source. If you go to the source, you will see that there is no syntax error. If any syntax error will be present, then you have to first correct that syntax error. After that only you have to do the simulation. Since there is no syntax error, now I'll go for the writing test bench. So I'll go again add source, then go to create add or create simulation source. Next, then here you don't have to give any input and output, only you have to create the file. So I'm writing that full adder underscore tb test bench. Okay, then we have to finish it and we have to okay it here. Next you will see that under this simulation you have a full adder underscore tb is there, which is a simulation source. Since it is a simulation source, it is only appearing in the simulation, it is not appearing in the designing source. So now double click this one, you will get the the test bench code you have to write here. So I'm writing the test bench code here. This is the code test bench code for that full adder design source, which is written in the Dataflow modeling. Now I have to declare three input variable, that is a underscore t, b underscore t, c underscore t. Then I have to declare two output variable, which is OR data type, input will be register data type. So output is sum underscore t, carry underscore t. Then I have to call or instantiate my module design source. So in the module, what is the design module I have given? Full adder underscore d1. That you can verify from here. I have given full adder underscore d1. Then full adder underscore d1 PUUT. Then we have to pass the input and output variables. Dot a underscore t, dot b underscore t, dot c in c underscore t, dot sum underscore t, dot carry underscore t. This a underscore t is representing the variable declared in the test bench. Capital A is represent the variable declared in the module or design source. Now since we have three input variables or three input, so whenever we have to give the initialization of the input, there will be 2 to the power 3, that is 8 different combination will be there. It will be starting from 000 to 111. So 000, 001, like that it will be, last will be 111. So after that we have to give the system function, that is $finish or $stop to stop that simulation after that. Then we have to, since here it is starting begin, you have to end it here and end module. Okay, now after this we have to save it. After saving, you have to verify that test bench should contain the design source. So you'll see here, this is the FA underscore TB is the test bench, and under that FA underscore D1 is coming, which is a design source. If it is coming, there is no question mark, that means it is a correct code. Okay, so after that we will go for the simulation, and it will take some time to get the waveform. So we are getting the correct waveform here. There is no errors. If errors will be there, then it will show here. You have to go to the message bugs, and there you have to find out the error and you have to solve it. Then you will get the output. So now this is the waveform. Then I have to click on zoom fit. So I'm getting the waveform here. Then by the help of the scroll bar, I will move the scroll bar, and I have to get what are the different input and output, and I have to verify. Let us take this case. In this case, what is the input? A underscore t is 0, b underscore t is 1, c underscore t is 1. That means the input is C011. So with respect to 011, the sum value will be 0, because 1 plus 1 is 10, 10 plus 0 is 10. 10 means 0 is the sum, 1 is the carry. So now it is coming correct. Like that, for any case you will take, you have to verify. Let us take another case here. So for this case, what is the input combination? 1 1 0. Same output will be there because 2 bit 1, 1 bit 0. So I'm getting sum is 0, carry is 1. So it is correct. So whatever code I have written, that is correct. Now let us write the same full adder circuits by the help of a behavioral types of modeling. And I will tell you what is the difference in behavioral type of modeling and this data flow modeling. We'll go to the add source. Again, add or create design source. Next, create a file. So we'll give full adder underscore b behavioral type of modeling. Okay, we'll finish it. Then we have to mention the input and output port. Same port we'll take so that the test bench we don't have to write again. There only we can use that same test bench for behavioral modeling as well as data flow modeling. A B, then A B comma C in. Output will be sum and carry. So here we have to select the input direction as output. Okay, so okay here. Then you can see in the source that design source will be created, that is full adder underscore b. Double click here, go to here and write the expression here. So since it is a behavioral type of modeling, the first thing you have to remember that the output must be declared as a registered data type. So it will be reg. Then what we have to do, we have to write the code in a always block. So we'll write always @a comma b. So this always block a comma b, this is your sensitive parameter. That means whenever these values are changing, then only the block will execute. After always block, again we have to write begin. Then we have to write the code. Previously in data flow modeling, we are using the keyword assign. Here you don't have to use any keyword. Only the output will be assigned in terms of input. So what is my output now? Sum equal to what is the output? A XOR B XOR C. Not C, the variable is C in. Next, another output is carry. Carry equal to that is A B B C C A we can write, or we can write A B plus A XOR B into C in. So how to write that one? You can write A and B. Then we have to give OR. These are the symbols, and ampersand is representing and one vertical line is representing OR. In bracket will keep A XOR B whole into C in. Then this begin you have started, that begin has to end. So we have to write end here. Then we'll save it here. After saving, again you have to see this window is showing any syntax error or not. If no syntax error, then you can go for the test bench. If any syntax error is there, then first you have to correct the syntax error, then you have to go for the test bench. Okay. So if you are not correcting the syntax and you are going for run simulation, then you will not get the execution. It will show errors. So now since it is showing correct, I can go to the test bench. Same way I can go to add source, then I add or create simulation source. But the test bench is same for all types of modeling. There, because test bench is nothing but it is the input, and input means it is fixed for all. Okay. So same test bench, whatever I have, I'll take that test bench. What I'll do here, I'll do the instantiation with my module. This is my module fa underscore b. So this one I will write in that module instantiation. So here what I'll do, I'll just copy this line. No need of writing the test bench every times if you are writing the code for same circuit. Copy this one, paste here. So what is my now module? That module name is full adder underscore b. I can write here, modify here. Then see, this is UUT is given, unit under test. Here you have to give some another name. Let us give design under test. Then remaining all variables we have taken similar, so we don't have to change anything. Then you can see here, without saving this full adder underscore tb simulation source is having only one design source, that is full adder underscore d1. Now I have to add full adder underscore b. By clicking this, by saving this full adder underscore tb Verilog code, it will come. So I saved here. Now you can see that under this full adder underscore tb, this fa underscore b is coming. Okay, if it is coming means then there is no errors in instantiation. So now we have to go for run simulation. Now if you will run, then you will get the output with respect to the Dataflow modeling code. Why? Because this is the top module. In the design source, this is the top module. So first we have to select this one, then right click, go to set as top. Then this will be the top module. After that we have to go for the run simulation. Now in the simulation source I am not changing any top module, because that same test bench code is used for both design source, full adder underscore d1 and full adder underscore b. So we don't have to write any top module, we don't have to change it. Now go for run simulation. Now the waveform will come. We'll verify the waveform from its input and output value. Now you have to click on zoom fit. Now I'm getting the waveform. The waveform will be, if it is correct, everything you have written the code correct, the waveform will be with respect to your previous only. It will be same. The waveform is coming with respect to the behavioral code you have written, but since both are with respect to a full adder, so output waveform will be same. Now you can see here. Now you can see here, if I am taking the cursor and I am keeping here, for example I am taking this first one, 0 0 0 input, output is 0 0. Again this 0 0 1, output is sum is 1, carry is 0. Then going to another case, 0 1 0, sum is 1, carry is 0. Similarly, if we take the last cases, for example 1 1 1 or 0 1 1, I am getting sum is 0, carry is 1. In last case, if I will take 1 1 1, I am getting this sum is 1, carry is 1, because 1 plus 1 is 1 0, 1 0 plus 1 is 1 1. The first one will be considered as sum, and second the MS will be considered as carry. Okay, this is all about full adder circuits by using this behavioral and data flow modeling styles and verifying with the help of a test bench. Now if you want to see the what is the structure, what is the block diagram of this full adder, then we can go to open elaborated design. It will take some time to create that block diagram and circuit diagram. So now you are seeing that this is the full adder. This sum 1i means what? This is a and b is given aggregate. then this another XOR gate will be there here, in that given this output plus this Cin. Okay, this is the circuit diagram of full adder. Hope you understand this topic in a good way. If any doubt will be there, please do comment in the comment section. I will try to rectify that. And thank you for watching this video.